say good afternoon for those in the afternoon, and then for those in the morning, good morning. So good day to everyone. Once again, welcome to another webinar. We're loosely from the words of a colleague. I say I'm giddy with delight to have you here today. So, very quickly, we'd like to have your feedback, as it's our custom. We want to hear what you have to say concerning the internship so far. And so today, I'm taking feedback on what do you think about the opportunity that Hamoye has given you to continue on the internship to the very end, to keep on learning, to keep on acquiring new skills regardless of how you fare in a particular stage. So I'll be taking feedback on that today. And so if you have anything to share with us, please, if you're on Zoom, just wave, signify by waving, raise up your hand, and then we'll ask you to mute. If you're on YouTube, kindly put your comments in the comments pane and then we'll read it out. So please, okay, let's have you. Show of hands, please, show of hands. Show of hands. Just tell us how you revel the opportunities to keep on learning till the very end of the internship. So nobody wants to share with us today. Anybody? Korede Okosi. You want to share with us? Just signify by show of hands, please. Okay, David, I can see you. David, kindly unmute and share with us.
Yeah, hi everyone.
Hi, David.
All right, so my experience, or I would like to thank Hamoye for the opportunity to continue. Actually, with my score in the two tests, I knew I was not going to cross. But when I read the news on Slack, I was like, wow, it's an opportunity to learn more. And so far, so good. I've been able to learn a lot because normally for me, if I was going through courses online, like on YouTube and all, I wouldn't have been able to see most of the things I've been learning so far. And I must say, thumbs up to Hamoye for this opportunity. Thank you very much.
Okay,
and thank you to
David.
everyone that's contributing to the group chats on Slack, on the Hamoye platform. It's been awesome. It's been awesome.
Okay, David. Thank you very much for sharing with us. So at this point, I would like to hand over to my esteemed colleague, Toby Dejimo. Toby, over to you.
Thank you, Femi. Hi, guys. Good afternoon. I'm excited again to welcome you all to today's webinar. I see people are already online on YouTube. We have a couple of people on YouTube already and on Zoom. And I think we can quickly comment now. I'm delighted to have you on board today, and you can use the live chat to let me know how you're feeling this afternoon. Olusegun Adeoshun is the first person to join us on YouTube this afternoon. Good afternoon, Kolade. Yeah, now just a little housekeeping rules before we start. If you have any questions, linguistic propositions, doubt, or uncertainty during today's webinar session, please wait till the end of the session to avoid lag or intermittent disruption during the session. You can leave your questions on Slido using the event code 99516. Now, without further ado, let's turn the table over to Shola as he has few words to say before we begin. Over to you, Shola.
Hello, everyone. Good afternoon. Welcome again to our Saturday's discussion on, of course, the future of data science, of course, across Africa. We're excited to have you join us again, and we have one of our specials in the house today who is going to be sharing with us. Last week, what we did basically, of course, provided some clarity based on the feedback we received about breaking into the space, and we decided it would be a good thing to take the conversation forward so that alongside your learning of the technical things, you are also developing across board the understanding how the career works and some of the areas you should concentrate to ensure success at the end of the day. So today we're going to be looking at something interesting. I won't spend too much time, but it's centered around feature engineering. And research says data scientists spend alongside in terms of the process, this is one of the areas you're going to spend the bulk of your time alongside data cleaning. After data cleaning, there's the feature engineering, then algorithm selection. So today we're going to spend some time to help you better understand feature engineering. And of course, we have our special Wale in the house to help you better understand this feature as it shares with us today. Thank you once again, Wale, for joining us. We're always happy to have you join, to welcome you.
Yeah, thank you for the introduction. I'm excited to join you guys again. So let me share my screen. Yes, I have the good logo now. Okay. Yeah, my talk should probably take between 30 to 45 minutes. And then after that, I think I'm probably going to use the remaining time to have a sort of ask me anything question. I guess just if you have questions on so in general, machine learning, the space, the state of the art, what are people doing now, and what does it look like in the future? I think I would be excited to answer that. So I could probably stay a little bit more than 1 hour if you guys want me to stay around. So today I'm going to be speaking about the nuts and bolts of feature engineering. And I think it's going to be a little bit exciting. And so this is how I'm actually going to go. I'm going to talk a little bit about me. Probably you guys already know me. Then I'm going to give an introduction to feature engineering and why is feature engineering important? How do you do feature engineering? And then I'm going to go into some of the features. How do you undo categorical features, and how do you undo numerical features? And how do you undo features with date, time, and coordinates? And then I'm going to talk a little bit about some other techniques, which is feature interactions and things like that. So just about me, I have a lot of X's. So I'm currently a data scientist at Amazon. Before that, I was leading a team in an energy company where we're working on the intersection of renewable energy and machine learning. I did some data science for HR optimization for one of the largest retail companies in the world. I used to be a physicist. I did a little bit of machine learning for development at IBM Research in Nairobi. I'm really interested in democratizing machine learning. That's why I actually buy into the idea of Hamoye. It's really exciting because I feel like everybody in the world should have access to this knowledge. And of course, I'm a Real Madrid fan, Real Madrid, and I used to be a semi-professional Scrabble player. So that's me in a nutshell. So let's go into the introduction now. I remember when I started machine learning, one of the first quotes that I saw was something from Andrew Ng that talks about the applied machine learning is basically feature engineering, which means that in some cases, for you to get the best out of your data, for you to get the best out of your algorithm, applied feature engineering, and feature engineering is actually extremely important. And so when you're doing applied machine learning, you can have all your algorithm, but the way you try to craft your features actually matters a lot. The way you undo your features, the way you craft your features matters a lot. This is another quote about more data beats clever algorithm, but better data beats more data. We talk a lot about, so if you're going from the machine learning to the deep learning space, you would actually see that there's some sort of linear continuity. So not really linear, but which means that you have more data, and you want to use deep learning because deep learning is extremely data intensive. You actually need more data for deep learning to do better. But then you get to a space where it doesn't matter when you add more data, it's just going to be the same. And that's when you start thinking about the quality of the data. And sometimes you can actually bring out the quality of the data by doing pretty good feature engineering. So what is feature engineering? Feature engineering is actually the process where you introduce knowledge into a machine learning model. So you have your ML model, you have maybe features given to you, and then you need to sort of turn those features into, engineer new features. That is the process of you introducing knowledge. Yeah. What are these features? These features are mostly the variables that you found in a given problem set that can actually help you build some sort of accurate predictive model. So, and I'm using predictive model in this case because I'm sort of in the realm of supervised learning. And so they represent the knowledge that is very appropriate for machine learning algorithms. I really like this slide deck a lot, which is me trying to explain what supervised machine learning is. And I divide it into two parts. So you have your learning part and you have your prediction part. And in your learning part, what happens, and this is what you guys have been doing for the last 3-4 weeks, is you have existing data and then you put it into some sort of machine encode. So this is your algorithm, right? Which means you train the existing data is your training set. And then you build a model for it, right? And then you take this model that you've built, and then you go into the prediction phase where you have new data, which could be either your test set or your validation set, and then you apply this model to it, and then you have your prediction. And that's what machine learning is. And this data is actually, in this case, it's a tabular data. So that's why I say it's several vectors of length D. And then so that's some sort of visual representation of what machine learning is. So why do you want to do feature engineering? Why does it even matter? Engineering features actually helps you to be able to accurately represent some of the underlying structure of the data that you cannot see. And and therefore you actually create the best model. And sometimes, in most cases, the features in your data, they influence the results that you can achieve with your predictive model. Let me give you an example. Let's say that you're in Lagos and you're trying to predict house prices in Lagos, right? And let's say you're trying to predict house prices, and I know some people are not in Lagos, but people that understand Lagos would definitely understand this analogy. You're trying to predict house prices, and they've given you, Lagos doesn't really have zip codes, so they probably just going to give you names of area, maybe Lekki and Victoria Island and different places, right? But think about it, the idea that they just said Lekki, it's not going to really influence your algorithm, because the people who stay in Lekki Phase 1, for example, the house prices are definitely going to be very expensive than those that probably stay in maybe Chevron or Aja, which is further away, right? So something you could do to engineer your feature is that you could think about a central location, let's say a shopping mall, which is ShopRite in Lekki, and you could actually take the coordinates, the latitude and the longitude, and then you could look at the difference or the distance between this house to where a major shopping mall is, or the Palms, and then you can actually use that as a feature, and that's going to be a very good feature, a very good indication of how of how expensive or how cheap that place would be. So those are examples of features that maybe you're not given, but because you can actually look up what the coordinates of this place is, and then they give you coordinates of houses, you could actually use that as a feature. So it can actually influence the results that your predictive model can achieve. Feature engineering has a lot of limits. I'm gonna try to explain this. In some cases, when you have very small data set, let's say data set with 100 examples, your degree of freedom becomes extremely small, because in some cases you don't have the flexibility to create new features. Correlation is important, especially if you're trying to feature engineer when you're using what I call the non-tree based model, which is linear models, in this case, linear regression or logistic regression. So you could actually include too much variables that are correlated. So that's a mistake. And this can actually decrease the model performance. And so that's why I call large P versus N. So think of it as P is your features and N is the number of training examples that you have. And so in this case, if your feature engineering or the new features that you're trying to craft, if they're too much, you actually go from this sort of small dimensional space to a very, very large dimensional space. Also, if you have too many variables, you can actually make your model less interpretable. And then I think about this interpretability accuracy trade-off. If you do like Kaggle competitions, right? A lot of the reasons why people do Kaggle competitions, when people do Kaggle competitions, they try to be very smart, so they craft new features, do a lot of things. But in some cases, real world data science is not Kaggle competition. There are cases where you're trying to, for example, you're trying to use machine learning in healthcare, which is some of the things I do nowadays. Or you're trying to use machine learning to determine if you're going to give someone credit, right? These are actually really high risk, very delicate missions that that you're trying to use machine learning for. And in some cases, because of some sort of compliance and some regulation like the EU GDPR, you actually need to be able to explain what your model is doing. And if you're using, let's say you're doing so many feature engineering and you're using like a model like an XGBoost, for example, that's going to be a problem. And so you need to think about interpretability, accuracy trade-off so that you don't over-engineer your features. And then in some cases, feature engineering actually limits your generalizability of models when it sees new data. And so sometimes you won't be able to do that. And in some cases where you work for, let's say you work for big tech or maybe Google or Facebook, where you're getting data every day, so you have to do some sort of online learning. In this case, it's very possible that when it sees new data, because you've over-engineered it, so those are the limits. Change there is extremely good, but like they say, sometimes good things, they also have their bad parts. Okay. It's feature engineering really hard. So I actually really like this image that I have. A few years ago, I was learning about someone. His name is JeanMichel Basquiat, who's an artist from, I think it's from Harlem in New York. He was a very eccentric character. He actually died in the late 80s. And this is actually one of his drawings or paintings. And you'd see and you say, what is this? Yeah. I'm not sure if it's this or there's one similar to this that was sold recently about 3 years ago for $110 million. And so that's how important Basquiat is. He's African American. And so I was reading a story of how he creates his art. And so in the creative process of Basquiat is that he actually planned a lot and practice. So which means he goes to like roadside murals and practice, 100, 500 times. And then after that, he just begins to create and improvise. So if it's going to be a roadside mural, he's going to use a piece of paper. He's just going to continue. And then he does a lot of review and he revises his work a lot. He adds things. You could see in this image, let's say, for example, the first thing is drawing as a crown and he has the skeleton. And then he decided, oh, I'm actually going to add some sort of, these paintings and this. So he does a lot of that. And then he also refines his thinking by trying to interpret and explain whatever he's doing. And then he shares and reflects. And so reflection is very good for him, which makes him sort of get better when he's trying to do next things. And so probably his arts, his drawings or paintings are definitely one of the most expensive in the world. I mean, for $100 million for just one painting, that's a lot. So that's how important Basquiat is. Now going from the world of Basquiat to feature engineering, in feature engineering, the creative process is that you also plan, you define your problems and you plan. So what are you trying to do? Is this a prediction algorithm? Are you trying to predict energy usage, for example, or are you building a recommendation system? If someone is trying to shop if you're a data scientist for Conga and someone's trying to shop and the person is looking for TVs, are you going to show the person the generator, for example, or what are you going to show the person? Are you going to show the person, tell the person to buy a shirt? So what problems are you trying to solve? Is it a prediction problem or a recommendation engine or computer vision problem? Then thorough understanding of your data is very important. I mean, remember before even this, you have to clean data, but also exploratory data analysis is really, really important. You need to know the kind of features that you have. You need to know the interactions between some of the features. You need to also know the model assumptions of the model that you're doing. And then you need to plan your feature engineering goals. And in some cases, when you're trying to put machine learning models into production, you need to know if you're optimizing for speed or you're optimizing for performance. And like Basquiat, you also need to refine your thinking by interpreting and explaining. So it's always good for you to test and for you to actually treat whatever you're doing. Okay, and now I'm just gonna go through some type of features. I'm mostly not defining the type of features, but how do you handle features like this? So I mean, some of us definitely already know what categorical features is. Categorical features, in most cases, you have to engineer them. Sometimes what you do to categorical features is that you do some form of encoding. And then the idea is encoding can actually lead to sparse data if you have very high cardinality. And sparsity in your data is where you have a lot of zeros, zeros, zeros. And you could have like a very large metric. So it could be difficult. It is difficult to impute missing data because they easily lead to some sort of over or underestimation of variability, and I'll explain this. And so when you're doing missing data and you have missing data for numerical features, the simplest method that you can possibly use is just impute with maybe the mean or the median in this case. But for categorical features, sometimes you'd have to just impute the mode. And the idea is that you're just imputing all the missing values by the one that has that is most common. And in this case, it can actually change this sort of variance of your data set. So those are some, that's definitely a limitation when working with missing data in categorical features. Okay, now so the most common method is actually used to represent nominal categorical features. It is easy to explain and it produces easily intelligible results, right? So let us look at this example. So now I'm actually talking about using one-hot encoding to encode categorical features. Let's say you work for a company that sells car, right? And you're trying to do some sort of prediction on what's the next set of cars that I'm going to get, and you're trying to look at the demand and maybe predict the demand and predict price. And you have this simple data that has a car ID. The first car is Honda, the next one is Toyota, then you have Toyota, you have Ford, you have Mercedes, and then you have this car, the miles per gallon, all right? And so, but you have this car manufacturer. And one of the things you want to do is are you going to use this in your machine learning model? And then you're going to do something called one-hot encoding. So how do you encode that? And so this is what one hot encoding is that you turn, so the car manufacturer under Toyota, Ford and Mercedes, you actually turn them into some numbers, right? So you can see for the first one is, so now you have under Toyota, Ford and Mercedes are all features, right? And then you have under 1000 Toyota 0, because Toyota is actually second and third car. You have this, and Ford, which is this, and Mercedes is this. So now you've actually done a one hot encoding of that feature, the car manufacturing feature. And so that's one hot encoding. So I mean, I probably mentioned this. Some of the drawbacks is that you could have too many features. And in some cases, it just becomes computationally expensive for you to train if your machine learning algorithm is very complex. If you have features, actually, one hot encoding is limited to linear models. If linear regression, logistic regression, or just GLM, generalized linear models, Poisson regression, and things like that. Which are also non-tree based model. What people have actually asked me this question. Actually not in most cases, you don't necessarily need one hot encoding if you're using tree based models. So if you're building a decision tree or a random forest or an XGBoost, there's no difference between you one hot encoding or doing linear encoding. It's going to be the same thing. Because you have sparsity, so you have a lot of zeros here. It could actually require large memory, and then you should also watch out for multicollinearity. And multicollinearity is a case where one or two features have very, very high correlation coefficient or coefficient of determination. And then the implementation of cost doesn't treat missing variables. So there's another one which is very straightforward. It's called label encoding. And the idea of label encoding is that you have a feature, and all you do is you assign a numerical value for each level of category. And then it actually assumes some sort of natural ordering between the labels, and it's very good for tree-based and non-tree-based model, linear models, for non-tree-based, tree-based, which is the likes of random forest and gradient boosting and things like that. And then the dimensionality of your model remains constant. So unlike one hot encoding where we went from this one feature and we use it to create 4 different features, in this case, all you need is your under is going to be 1, your Toyota is 2, Toyota 2, your Ford is 3, and your Mercedes is 4, right? So you have some sort of natural ordering, and you're just assigning numerical value to each level of category. So that's label encoding. Okay. This is another interesting one, which is count encoding. What you do is that you change your categorical variables with the number of counts of each variable, right? So, and you can use it for both tree and non-tree based. It is sensitive to outliers actually. And sometimes you could have some form of unwarranted interaction. What I've seen people do is that if the count is a little bit skewed, you can do a log transformation. And this is what I'm saying. Under is just appears one time, and then your feature count is just going to be 1. Toyota actually appeared twice, and your feature count for Toyota is going to be 2. Ford appeared once, and it's going to be 1. Mercedes, and it's just going to be 1. So that's what a count encoding is. This is another one called label count encoding. What you do is that you count the categorical variables and rank by number of counts, and you can use it for both tree and non-tree based models. So let me show you what I'm saying. So if you count Toyota on this feature, I've actually just expanded and added more stuff to it. Toyota is 1, 2, 3, 4. So Toyota appears 4 times. Under appears twice, and then Ford and Mercedes appear once. So So the label count is that because Toyota appeared 4 times, it means that it's 1. So that means you've already counted it, and then you give a label to the count, right? So the highest number of counts is labeled 1. The next is second. So under appeared twice, which is second. So 2 times, and for them said is 3, 3. And so that's label count encoding. This is another one, which is called target encoding, and so I'll explain what that is. So in target encoding, the categorical variables, you encode them using the ratio of their target counts to their variable count. It is a little bit tricky because you could have some correlations between these encoded features and your target variable. It is actually good for a large number of features. I've seen a lot of people who do Kaggle competitions and win prizes. They say it's their best kept secret. They also try to add some sort of random noise so that it doesn't overfit. And this is what target encoding is. I'll explain. So what you're doing is that you have under, so you could see that you have sorry. So you have under, and the feature count for under is 333, and you have Toyota, so which means it's counting, right? So Toyota appears 5 times, right? And so what you're doing now is that you're taking, so this is the target. So the target is maybe, should I buy or should I not buy? So it's a binary classification, so 0 or 1, right? So you have 0, 1, and 0, right? For just under, and you can see that it has just 1 here, right? And which means, so this one, so what you do is that you take the target and then you divide it by the feature count. So 1/3 is going to be 0.33. So that's how you have, this is your feature target. For Toyota, your ones are 1, 2, 3. So your positive targets are 1, and then you have 0 and 0. So you have 1, 2, 3, and you take this 3 if you count it, and then you divide it by this feature count, 3/5, and that gives you a 0.60. So that's what a target encoding is for binary classification. And I've seen a lot of experts, Kaggle experts, say it actually helps them. It actually improves their model in this case. I'm going to talk about numerical features next. I know that we want questions after, but if we have questions now, I think I might be able to take maybe 1 or 2 questions for I continue. I always like some sort of interactions or feedback or questions in the middle. I can hear you. I hear you. Can someone else say something?
Okay, Wale. So they can raise their hands, and once they raise their hands, we can unmute them.
Okay.
That's on Zoom.
I think Shola was trying to say something that we cannot hear him. Can you hear him?
Shola. No, I can't hear Shola also.
Okay. Someone raised his hand.
Okay,
yeah, can you hear me?
Yeah, I can hear you.
Yeah, you talked about label encoding. So, for example, Honda is 1, maybe Toyota is 2, then Mercedes is 3. Is there not is that not a problem when it sees it as an hierarchy? For example, it sees or classifies Honda as having more weight than Toyota. Is that not a problem?
It is definitely a problem. Because it assigns some form of natural ordering. It could be a problem in some cases, but also we already know that from the model or from the features we don't have any ordering in it. But assigning it, it is fine, and the reason why it is fine is if you don't have a lot of categorical features. So let's say, for example, in this space you have all the cars in the world. I mean, under the Tesla, a Mercedes, a Ford, you have like 50, right? And then it has to order them 1 to 50. Then that might be a problem. But if it's very, very small, maybe 4 or 5, that should be fine. But yeah, it could be a problem.
Okay.
Does that answer the question?
Yes, but I was thinking the one you said, I guess that's one auth encoding where you have 1 for one and 0 for the other ones. Yeah. I was thinking probably it's like the best thing. I don't know. And I'm new into the field of machine learning, but you said it can lead to complexity. So
So that's it's actually it's the best. I use it a lot. The only problem is that let's assume that you have all the cars in the world, right? Think of the amount of additional features that you've created with it, right? So you begin to have like this really large matrix with a lot of zeros, so it's very sparse. So that could be a problem.
Yeah. All right. Thank you very much.
You're welcome. So I'll take one more question and then I'll move on.
So let me unmute Amos.
Okay. Hello.
Hello?
Yeah, can you hear me?
I can hear you.
Okay. So now I'm trying to do all this encoding, either of any of the encoding that we do. Probably we now go into our machine learning and that means we have a model at hand that we can always use for our machine learning or any other data that we want to predict eventually. I mean, the test data. So now, does it mean that the test data we are going to use, we have to go through the same process our training data goes through? Like if probably we are trying to predict something on the particular test data set. So does that mean that we have to do everything we do into the training data that actually give us our model on the test data?
Yep, exactly. Because remember that you're actually, when you do model.fit, you're saving the model. And so your test data, the shape and the dimension of your test data has to be the same. So you have to do the same transformation. So, and that's why in some cases you can actually make your feature transformation or your feature engineering as some sort of pipeline. So if you're using scikit-learn, you could use libel encoding or one-auth encoding. Even pandas has something called pandas.getDummies, for example. So you could use that. And so you have to apply the same thing to your test data.
Okay, so the major challenge right now is that what if I have a model at hand and the person using it now does not really know how I actually encoded my categorical variable. So does it mean he has to actually get through to the person that actually made the model to know how he got the model before?
I mean, exactly. I mean, that's why in most cases it's very important to have it's very important to document. So that's where documentation comes into place. If you document, and then the person will be able to see that these are actually the steps, and I need to sort of apply this same encoding to my test data.
All right, thank you very much. Then again, one more question, please. So
sure.
Out of all these categorical encoding, which of them can we say it is safe, like averagely safe for any of the model we are trying to use?
None.
Okay.
When you say safe, I understand what you're trying to say. But the thing is, they all have their own drawbacks, right? So, for example, I would have easily say, one-auth encoding is safe, right? Yeah, you're gonna always want to use it, but if you have very large categorical, like where you have a categorical variable with very, very large number of categories, you could have an issue with that if you don't have compute power. It could take longer. So, but if you want to say if your data is not that much, I think why not encoding 200?
Okay. All right. Thank you.
All right. Thanks for the question. Okay. So let's go on. So the next one is numeric features. I should be able to breeze through this. And so, I mean, numeric features, you guys already know what numeric numbers are. There are a lot of methods that you could use. You could actually bin. So binning is where you convert a numeric variable to discrete variables. You could also do some sort of conversion, which you can do. So you do conversion by declaring a range of values. So think of binning, let's say you have some data that has you're trying to predict the very cool data set I was showing you, and then you have the age of the data. So let's say a car that was manufactured in 2000 is old. Let's say you work for Uber, right? Or some sort of car ride sharing company. And the ones that are within the last 5 years is new. So you could do something like that. So there are two types of binning. You could have a quantile based binning where you sort of segment it into some quantiles or percentiles depending, and then you can bin them. And you could also do some sort of fixed width binning. So you can determine the width of the bin and then you use it to bin it. Rounding, I actually like this a lot, which is, so sometimes what you do when you round is that you round, it gives you the ability to keep the important features of the data. It can also help you remove random noise. You can actually round to form categorical variables. Remember what I mentioned, that feature engineering is your ability to intelligently sort of craft features by transforming the features you have already, right? So you could see you have this MPG, which is the miles per gallon, 23.2. You could easily round them to the nearest numbers. Another thing you could do is that you could actually just take this and you could just take this first, 22132. This is also a way of rounding. And I've seen people use this to actually improve their results and create new features with it. I mean, you guys have probably used min-max scaling a lot. So scaling and normalization is also good, especially if you have data that is not normalized, that has the degree of skewness is pretty high. And so min-max actually scale the values towards the mean of a column, and this is what it is. And then you could do a z-score scaling. If you don't want to lose the impact of outliers, you could do that. And in this case, your mu is the mean and your sigma is the standard deviation. So you could do that for scaling and normalization. Logarithmic scaling is also good. You calculate the log of the values so that you can narrow the range. Also, you do this a lot, log transformation for linear models, because it changes the distribution and it actually helps to improve the performance of this model. This is another one. I call it libel engineering and transformation, which is called the Boxcox. So one of the assumptions for linear regression, for example, is that you actually want some sort of multivariate normality. And so if you have some sort of heteroscedasticity in your feature, the Boxcox is a transformation that helps you remove that. It makes it normally distributed, and so which means that all you're doing when you're doing this Boxcox is that you're doing a transformation to find this lambda value, and the Boxcox becomes a logarithmic transformation if you have lambda, when lambda is equal to 0. If you're pretty good with calculus, if you take limits as lambda goes to 0, this stuff will give you a logarithm. And then it's also useful when you're selecting a transformation for linearity or normality. And so that's the Boxcox, right? And so if you look at this Boxcox, it assumes that the values, your numerical features are positive. So because think of it, if y is negative, the log of negative numbers is it's going to give you an error, right? So it has assumed that. So which means that in most cases the Boxcox is not going to work for a lot of transformation. And so when you do a Boxcox, right, this is what you get. So this is before. You could see it's very skewed, and now you sort of have a little bit some normality now after the transformation. Okay. So this is another one called the UJohnson. And so because the Boxcox is restricted by the value of y, you could actually do the UJohnson transformation. What the UJohnson does is that it's a new family of transformation that you don't have to place any positive value restriction on y. So if y is less than 0, for example, look at this last one, right? If y is less than 0, if y is -1, it just comes and do -1, -1 times minus. So now your log is positive, right? So that's what the UJohnson is. It gives you values for when y is greater than 0 and when y is less than 0. So it's a very good transformation, probably 10-year-old, that you can use if you really want your features to be normal. You could also do something called the adjusted log transformation, but it doesn't give you some sort of perfect normality in this case. So next is datetime and coordinates. I probably mentioned that. So you could have a lot of dates and time in your data. So you could have your periodicity. So what's the, you have features and they give you data and you're like, what am I even gonna do with this date, right? You could actually brilliantly create features from dates. You could say, oh, okay, because the dates of that this occurred in the data is August 15th, and August 15th is 2020 is a Saturday, or August 13th is a Thursday. You could actually use Saturday is the 6th day of the week, depending on how you counted it. So you could use the day number of the week as an additional feature. You could use the day number of the month as an additional feature. You could use the year as a feature. You could use the season. So you could go back and say, because this occurrence or this part of my data is in December, then I can create 2 seasons, holiday season and non-holiday season, right? For example, just think of people that predict the number of ride shares that Uber or Lyft are gonna get, right? They know that during peak season, it's very possible that the number of ride share or the number of people who are requesting actually goes up dramatically or exponentially. And then they could create additional features from that, which is the season. So that's good. And then I have this number left until recent holiday, right? So again, I'd like using ride sharing. Let's use a logistic company. So you actually work for a company that wants to predict what's the time. So let's say you work for a delivery company that goes take goods that someone buys and then delivers to them. And then every time what you want to do is that you actually want to predict the time that it will be delivered from picking up, right? You actually know that when it gets closer to the holiday, then there's more traffic, more people buying things. It's getting to the end of the year. It means that most likely the delivery time is going to go up, right? And so those are some of the things that you could brilliantly craft features that would actually give you very good signal. Or you can also pick some sort of random date. And then you could also use differences between dates. So datetime feature 1 and datetime feature 2, maybe when, the difference between when the person picked the goods and when it was ordered, or things like that. So you could use that to create new features for data time. I think coordinates are also very important, and I've also explained that. And one of the things you could do with coordinates, you could actually make them and you could do some sort of unsupervised learning. You could find the center of clusters. So you could cluster places the housing example that I gave is you cluster places in the mainland together, houses in Ajah together, houses in Lekki together. So you could do that. And then you could also do the distance to the nearest point or a major hub. And then you could do aggregated statistics, right? Sometimes you would see that the density of a particular area could actually maybe affect the price of houses. So you could do the density of, let's say, the Lekki, for example, is probably different from the density of, let's say, some sort of maybe Oshodi or so, just somewhere. So it could actually affect it. For tree-based models, you could include a feature that where you can actually describe, you could rotate the longitude and the latitude, and that can be useful. So, and this is what sort of rotating longitude and latitude is. So you have the longitude and latitude that shows like high price district and low price district. You could also just rotate it, and then you could have some sort of this high and low. So that's something you can do to coordinate. And then I have, let me see, okay. I have other techniques. And so the summing of feature crosses. In some cases where you're doing models, most times you want linearly separable model, but you could also have, linearly separable data. You could also have data that are really funny like this, that are non-linearly separable. And so feature crosses is sort of an artificial feature where you apply two or more input features together to encode some form of non-linearity. And so you have this non-linearity, but you want to make a linear separable. I mean, there are a lot of methods that you could use directly. But if you're using, let's say, a direct, like logistic linear regression, something that wants it to be linearly separable, then this might become a problem. And so you could create different features. You could create a new feature X3 by multiplying two features, or a new feature X4 by just squaring feature X1 like that. And then these newly created features, you're going to add them to your linear model formula. And now you have this X1, X2, and then this X3, which is equal to X1 times X2 and X4, which is this. And the only thing is that when you start creating feature crosses, it could be computationally expensive, but you can train them efficiently using this method called a stochastic gradient descent that actually sort of does gradient descent over the sum of the number of training examples. So feature crosses are pretty interesting. And so in conclusion, I mean, I'm going to go back again. Always try to define the problem and your plan. What kind of methods are you working on? Is it prediction? Is it recommendation? You need to thoroughly understand your data and your model. EDA is always important. The model assumptions are also very good, especially when you're doing linear models. You need to know for linear model why, like you have to use encoding, for example. You have to do some transformation, min-max scalar, something that normalizes the data, because it's one of the examples. So plan your feature engineering goals. Are you optimizing for speed? Or are you optimizing for performance? Then always try to refine your thinking by, interpreting whatever you've done. So, testing and doing some sort of iteration. So this is, feature engineering is huge. I mean, I didn't talk about engineering with text and natural language processing. That's another thing entirely. But this is mostly engineering, feature engineering with tabular data. This book is actually pretty good. Feature engineering for machine learning. I probably have a soft copy somewhere. Written by Alice Zeng. I've forgotten, she used to work at Concor. And then there's Amanda Kasari, who works at Google now. So I know both of them. The book is actually pretty good, gives a very good overview for feature engineering. So it's a good reference. I think I have a soft copy. I'll probably check and send to the organizers if anybody needs it. So yeah, that's me. Thank you guys.
Thank you, Wale, for your awesome presentation on the nuts and bolts of feature engineering. Wale's words are like light bulb. They charge you up to your higher self and provide so much clarity. I find this most striking. More data beats clever algorithms, but better data beats data. Feature engineering is truly a creative process. Now, moving on very quickly, we have some questions here for you from YouTube and Slido. The first on my list is from Olusegun Adeosun. So he's asking, I'm currently doing research to enhance an existing risk identification model for project management. How do I select the algorithm to use? Would that be classification, regression, or which?
Okay. Yeah. So you said risk identification. I mean, it just depends on one, the scope of the problem, and just depends on what the target variable is. So I probably wouldn't say if it's a regression or an identification problem or a classification problem. So it depends on the data that the person has. So you say risk identification, right? So it could be, I don't know, maybe if you want to predict if it's a risk or not, that's a binary classification. But if you want to predict some sort of score that defines the risk, then that's going to be a regression problem. And then if you don't have a target variable, then that's not even a classification or regression. That's going to be an unsupervised learning. So I would say, yeah, it depends on the data and the scope of the problem.
All right, thank you, Wale. Here is another from Matthew. By default, is libel encoder applied to output variables and one hot encoder to predictors? Or can you apply them irrespective of whether it is predictors or responses?
So yeah, that's a good question. I think no, you can actually apply them to both. If you're doing deep learning, for example, I know the target responses actually you need to one-hot encode, and sometimes it just depends on the libraries that you're using. So yeah, you could apply them to both.
Okay, another from Emmanuel. So Emmanuel wants to know the best way to handle categorical features with lots of subclasses and categories in them, e.g. trying to encode the 36 states in Nigeria.
Yeah, that's a good question. The safest way, if I'm doing it, is that I'm going to one-hot encode, unfortunately. But also I'm going to be ready that I'm going to be trading for longer. But that's what I'm always a little bit skeptical of libel encoding, because it you know, you have 36 classes. It's just gonna encode some sort of natural ordering between them if you're doing libel encoding. So that's one thing you could do. Another thing you could do is that, depending on the problem, you could definitely go a little bit more clever and create features for the geopolitical zones. So now what you've done is that you've created an additional feature that has just 6 categories: northwest, south, south, southeast, or whatever. Also, another thing you could do is that if your feature has places, you could take Abuja, for example, as a center, a coordinate, and then you could find the distance between the states to Abuja. And that's another feature that you could create. So yeah.
Okay, thank you, Wale. Joe says, how essential is feature engineering, particularly in today's era of deep learning, where feature selection is in some senses already implicit in the neural network?
Yeah. So when you're doing deep learning, just throw your feature engineering into the trash, unfortunately. Yeah, so yeah, that's a good question. Deep learning already does feature engineering at the network level, right? So in most cases, you don't need it. But the idea also is that there are a lot of models in production that are not deep learning. You need a lot of data to do deep learning. Deep learning is not interpretable. You cannot, in most cases, it's very difficult for you to explain. But if you're trying to do tabular data with deep learning, you don't need feature engineering to improve your model.
Okay, thank you, Wale. Now, in an enterprise environment, how do you manage the art of creativity in feature engineering, considering the time factor? Deliverables are mostly time-bound. This is from Mayowa on Slido.
Okay, yeah, that's a good question. I mean, that was one of the reasons why I was sort of mentioning. I think it was. Just give me a minute. This slide where I said you just have to define and plan. So planning your feature engineering goals is extremely important. That's why sometimes it's like, because when you over-engineer your features, it could become very slow, right? So I would say in the industry, you just have to plan and you need to look at the trade-off. So are you really optimizing for performance, or are you going to sort of give up some speed? So I would say it depends on the product or the feature you're trying to build, and also it just depends on what you want to achieve.
Okay, Odeshino Abdul Quadri on YouTube wants to know the best type of encoding to use when you choose to employ a tree model.
Oh, okay. Okay, I mean, there's no best for those that understands Occam's razor. So but the thing about three models is you can use any one of them. It doesn't matter. But what I remember, I was saying something about that in most cases you don't see a lot of differences between one hot and libel encoding. But you can definitely use any of them depending on your goals. Yeah.
Okay, Amos needs clarification. So
Okay.
is one hot encoding the same as using dummies? I mean,
Yeah,
pandas.get dummies.
Yeah. And I think I mentioned it. Yeah, it's the same thing.
Okay, Shadrach.
But I'm going to say something. Pandas.get dummies is very slow.
Okay.
Yeah, it's because I use so generally I have, for me, I don't know if other people, if they go through that also, I have a love-hate relationship with pandas. So it's extremely good. You can do everything you want to do with pandas if you have small data, but as your data grow, it becomes the most inefficient thing ever. So, but yeah, pandas.get dummies is the same. I try not to use it though. I try to just use one hot from scikit-learn.
Okay, thank you so much, Wale. Shadrach, I would love to ask how to encode categorical data that are ordinal, and how we handle a nominal data.
So how to encode categorical data that are ordinal, and how to do a sort of nominal data. So you could use a lot of the methods that I mentioned, but the ordinal part is very tricky because you also need to sort of find a way to encode the interactions between them. I would say, yeah, some of the methods can work, but you have to just be very cognizant of the interactions, and you also want to know how because, for example, you want to know the sort of degree of relationship between this ordinal data. So yeah, a lot of the methods can work, but I don't think I know which one specifically will be the best.
Okay. When having missing data in an object categorical column, is predicting those missing values advisable?
Yeah, gosh, this questions are like questions where there are no answers. So I could go on and talk for 1 hour about the missing value. So so it's a lot of things, right? If you have a data or a column and 80 or 90% of it is missing, you should probably delete it. It's not going to do anything for you. If you have maybe 10 or 20%, you could encode it. So that's why it's not a clear-cut answer. It depends on your data. It depends on what you're trying to do. It depends on what you're trying to model. And also, even though we talk about missing data in the context of you just using your measures of central tendencies to fill them, so mean, median, and mode, you could actually get much deeper than that. There are people that all they've been doing all their life is actually missing data research, because sometimes your missing data can actually depend on another missing data. Sometimes your missing data can depend on some sort of variables that you don't know about. So I would just say, just understand the missingness. Oh, okay, perfect. I actually wrote an article on missing data somewhere on Medium, that where I talked about you first need to know why it's missing. And also you need to know, sometimes in the industry, data they're missing because of maybe processes. And then you could easily retrieve those missing data. So that's the first thing you need to do. Just talk to people about why it's missing. And then if it's like 10 or 20%, then you can safely replace the missing data. If it's more than that, then you get to that boundary where you need to think deeply about what you want to do with it.
Okay, Ademide Adewale on YouTube wants to clarify this. Can the rounding technique for encoding be used to group and encode number ranges? So let's say from 10 to 15, 1, 16 to 22.
And that's binning, right? I think I explained that. Yeah, you can use it, Ademide. So that's I have it somewhere. Sorry. I thought I had rounding and I had binning. So you could actually bin and then round. So it depends. Yeah, you could do that.
Okay. And features do not exist in one place. How do you know the features that will affect the labels?
How do you know features that would affect it? So another brilliant thing you could do is build your machine learning model, train, apply to your test set, and then try to find your feature importance. And then when you find a feature importance, you see the ones that are important, and then you can still then go back again to feature engineer, and then create features, and do some sort of transformation. So yeah, you could do that. And then in some cases also, there's some feature selection techniques that you know the ones that would eventually affect your model, the ones that are very good signal. So.
Thank you, Wale. Daniel, this is from Daniel on YouTube. So I heard him say along the line that we can impute variables in the data as part of the feature engineering data. Is this truly possible with a real world data? If so, how?
That we can
impute variables in the data as part of the feature engineering data. Is this truly possible with a real world data? If so, how?
Yeah, probably. So I mean, you could say imputing missing data is part of feature engineering, because you have some sort of missing data and you're imputing. So it's just part of missing. It's part of feature engineering, and in real world data, people impute missing data all the time, depending on the kind of problems that they're solving. So yeah, you can always do that.
I thank you, Ali. Here is the last question for today. I have two questions. This is from Ade. How did you apply for a job at Amazon? And secondly, how are you knowledgeable in the other fields like web development, or you only focus on data science?
So how did I, I was probably lucky. For Amazon, I did not apply, and I wasn't even looking for a job then because I had the job. But they reached out to me. So recruiters do reach out to me. So they reached out to me, and they reached out to me many times, and I told them no. And mostly was because I wasn't flexible enough to move. I don't want to leave where I'm currently to move to another city. And then, but this opportunity I basically work 100% from home. So which means I can still be with my family. So yeah, they reached out to me. What was the second question?
Are you knowledgeable in other fields like web development?
So right now, apart from data science and machine learning, I know a bit of DevOps, so which means I can take a machine learning model and I can actually put it in production. So I work for Amazon, so I use AWS every day. So which means I can do that. In terms of web development, I wouldn't say I'm knowledgeable, but I've written React in the past. I've written React, a little bit of Node.js background. I've used D3.js for building interactive visualization. And then I said I used React for front end. And when I did it, I actually noticed that I was extremely poor at it. It was horrible. Jesus. Especially trying to do front end without a UI UX person. That was horrible. But yeah, so when I did it, the idea was that I was actually building an algorithm and I was trying to do some sort of front end dashboard with React and a Node.js backend that connects to our data is in NoSQL, which is Apache HBase. So that was an interesting 4 to 5 months of my life. But yeah, I would probably say my knowledge in web development is basic, beginner level. Yeah.
Amazing. Thank you so much, Wale. It looks like we've
Thank you.
covered a lot of questions today.
Okay.
Is there anything else you'd like to say before a final wrap up?
No. I was just hoping people are gonna ask questions generally about the program, the content, just general questions. But if that's all the questions we have so far, I think that's fine. I don't have any question. I don't have anything else to add. Yeah.
Okay. Awesome. Thanks again, Wale. Thank you, everyone. We appreciate you for being here. Thanks again for joining us today, and we'll see you another time.
Yeah, sure. Yeah, thank you so much, guys. Yeah.